Good morning, and thank you for joining us for today's Research Over Coffee webinar. I'd like to start by acknowledging that we are in Mi'kma'ki, the unceded and ancestral territory of the Mi'kmaq people. We are all treaty people. We also acknowledge the histories, contributions, and legacies of the African Nova Scotian people and communities who have been here for over 400 years. I'm Dr. Alice Aiken, the Vice President of Research and Innovation at Dalhousie University. I have the distinct pleasure today of introducing our speaker, Dr. Wayne Groszko. An expert in energy sustainability, Wayne runs the Applied Energy Research Lab at the Nova Scotia Community College. There, he leads collaborative research projects with industry partners to advance sustainable energy technology with a particular focus on solar energy and energy storage. Wayne is also an adjunct professor and instructor at Dalhousie. In Nova Scotia, we're working toward 80% of our electricity supplied by renewable energy by 2030. To meet this commitment, there's a pressing need to identify and develop energy storage technologies. This morning, Wayne will discuss various energy storage technologies and their potential application in Nova Scotia. After Wayne's presentation, we'll be taking questions using the Q&A function of this webinar. I'll now turn it over to Dr. Wayne Groszko. Wayne.
Thanks everyone for joining, and thank you, Dr. Aiken, for great introduction and really setting the stage. So as was mentioned, I'm Dr. Wayne Groszko. I'm going to go rather briefly through some of the energy storage work that we're working on and really the context of how that fits into the future that we need to see in terms of decarbonized energy systems. And this is just the overview. I'm going to speak about the introduction to what we do and the problem, the opportunity, the challenge that this need to decarbonize presents, and some of the solutions, including solutions that we have the great privilege to work on within the lab that I manage, which can be very fun sometimes too. And talk a bit about at the end about how can we scale these things up, because obviously they need to be scaled up to meet the enormous challenge that we're facing and really seize the great opportunity that is presented to us. I won't spend a lot of time on this because Alice already basically described it. We work on practical applied research and development projects with industry and community. And in doing so, we get some great opportunities as well for faculty and students at the Nova Scotia Community College to learn and to become really the future leaders and workers in the sustainable energy transition. The opportunity that we're talking about, I think most people in the room are quite aware of, and that is decarbonizing essentially our entire energy system. And in the Nova Scotia context, that means that we're bringing on a tremendous amount of wind energy. Certainly wind energy is number one. You see the large wind farm developments, and there are more to come. There's a good reason for that. It's currently the lowest cost of new carbon-free electricity, a lowest cost source, and the resource for it is fantastic in Atlantic Canada. Solar as well. We have a kind of a mid-range solar resource in Atlantic Canada and in Nova Scotia in particular. It's actually pretty good. And solar has a different attribute in that it's very flexible. It can be deployed effectively right down to the scale of a single building. So that's why you see it distributed among really thousands of buildings now in Nova Scotia have solar energy installation that's connected to the grid. So that's growing as well and quite rapidly. Tidal energy is a longer development phase, but definitely has enormous potential. But what all of these sources of energy have in common is that their output varies, and it varies based on the supply of the resource that is driving them, being the wind, the sun, the tides. Now, the tides you can predict years in advance, so that's kind of an advantage. But still, tidal high maximum tidal power may not come at the time when you have peak demand. Just on that point, wind energy has additionally good characteristics because it tends to be stronger in the winter, which is when we have our high heating demand in Nova Scotia. So that's a really good attribute. But still, all of the variations in these kinds of energy production are a challenge that we need to face in order to seize this opportunity. So that challenge is essentially managing the supply and demand on the electricity grid, facing this increased variability, facing potentially increases in peak demand as more electric vehicles come on, as people switch to heat pumps. You know, to decarbonize those parts of the energy system, we're planning to rely a lot more on electricity for those. But what will that do to our peak demand? And, you know, everything from energy efficiency to demand shifting to all of those things are important in helping meet that. And I'll be talking a bit about that a little later on. What you see pictured actually, and I took this picture on my way to work this morning, that's the Tufts Cove generating station in Dartmouth, Nova Scotia. And that is primarily gas-fired, although they can run fuel oil through it as well. But that was on this morning in order to meet some peak demand. And that's a good example of how demand is met largely in Nova Scotia is natural gas, oil, and in some cases coal power plants, although they take longer to ramp up and down. Obviously, we need solutions that get away from the fossil fuel aspect of meeting those demands. So what are some of those solutions? I've listed 3 categories, and I don't think of them as mutually exclusive. In fact, I think of them as complementary. I think we're going to need all of them, essentially. Stronger transmission connections in the region. So you hear there's plenty of discussion about the Atlantic Loop, and we're already hopefully soon getting greater amounts of hydroelectricity from Newfoundland and Labrador into Nova Scotia. And just that whole being able to share, and particularly being able to share with regions that have a lot of hydroelectricity. And in our case, that's Quebec and Newfoundland and Labrador, obviously, because that balancing factor of, as we install more and more wind turbines, it's very, very important to be able to back that up. And hydroelectricity basically represents storage if it's stored behind a dam. So that's important. Centralized energy storage means within Nova Scotia, installing at locations where you can store energy and use it in bulk scale at one centralized location on the grid. And what's pictured here is actually a great example of that. This is a photo from the Bath County Pumped Hydro Storage Station in Virginia, United States, which is the largest pumped storage hydroelectric facility in the world, providing 3,000 megawatts of stored energy. And I mention it because I think, just from my own research and understanding of the issues, that pumped hydro storage is a really good option. It involves water. It does not involve large quantities of metals for making batteries, for example. And it requires essentially topography where you have high area and low area, 2 reservoirs, and you pump the water back and forth. We have those characteristics, especially in Nova Scotia and in Newfoundland as well. But centralized energy storage can be much more than that. It can be large batteries. We have one already, a megawatt-hour battery as a test pilot in Nova Scotia. The third is distributed energy storage. And I'm going to spend a fair amount of time on distributed energy storage in principle because A, I think it's a big part of the solution, and B, it's what we're called on to work on a lot in our lab. So we work with a lot of startup companies. We have a good pulse on what's new in the industry, and the number one thing people are asking us to work on with them is new ways of implementing distributed energy storage. So there's certainly a lot of interest there. So what is it? It's energy storage at the customer level. So right down in an individual building, if that's an industrial, commercial, residential building. And the picture is a really good example. So this is a prototype built in our lab. It's a stationary battery. What's really cool about this battery is that it's a repurposed second life battery out of hybrid electric vehicles. So the battery was no longer needed in the vehicle. Now it can provide backup storage this would be big enough for kind of like a house. And what we've done in the prototype is just shown an example of, conceptually, what would you do with this? You could use it when there's a power outage, you can plug stuff into it, you can plug an electric vehicle charger to it. And we'll talk a bit in a little bit moment about the potential role of electric vehicle chargers in all of this scenario. But there's one example. And the other, so that's a stationary battery example. But what's a little bit less talked about, I would say, but it's important, is that there's energy stored in all kinds of our systems, or the potential to do so. Home heating, which actually is one of our largest energy consumption processes. To be able to store heat energy and then use it for when you need it later will help solve this problem. Similarly, a hot water tank, and we'll talk about that in a minute. And then the energy that's stored in electric vehicle batteries, I think, is going to be a huge future source of distributed energy storage on the grid. Just briefly through a few examples of projects that we've been working on with industry partners. So thermal energy storage, these are units where they take in electricity when it's cheaper, or when there's more wind power, or however you've set up the algorithm, and they use it to store up energy, and then later on they put that energy back into the building and cut the demand on the grid. Now that's not new. Electric thermal storage units have been available for a long time, but these ones are based on phase change materials, which have, they're more advanced. They have better longer term storage capability. So that's something we've been working on, and I think it has quite good potential. Similarly, hot water tanks, ordinary electric hot water tanks, that tank that's pictured, that's an experiment in our lab where we're testing out, this is one of the early tests in Nova Scotia of the shifted energy hot water tank controller. And there are other brands on the market, but a colleague of mine, Forrest, maybe actually in this call, that's their company, Shifted Energy. What it does is it helps reduce peak demand on the grid by wirelessly controlling when that water heater comes on and off. And the user doesn't even notice, because there's all that hot water already stored in the upper part of the tank. So that's the key part, is making sure that the user doesn't notice that, hey, the water heater's been turned off during the period of peak demand. Now, just to get a sense, we can often say, well, okay, what's one water heater? But there are hundreds of thousands of electric water heaters. And just to rough back of the envelope, if you had these on 100,000 water heaters in Nova Scotia, you could shift about 150 megawatts of demand. That's significant. That's very significant. And it doesn't cost that much. Like there's more energy stored in this hot water tank than in a Tesla Powerwall battery. But the cost of this equipment is so much smaller. So I think it's worth a look. And definitely that's the case. So Efficiency One and Nova Scotia Power are already moving into programs to incentivize and promote this kind of equipment. So to speak about electric vehicles as grid support, and I think this is a huge upcoming opportunity, because we're seeing a large-scale shift and growing shift to using electric vehicles. And the battery in an ordinary electric passenger car is much larger than what the battery you could probably, most people could afford to install in their home. So if you've bought an electric car for other reasons, like the low operating cost, or you've got an incentive, or you just like it, they're going to be ubiquitous. And they have very large batteries in them, relatively speaking. Being able to tap into that battery capacity when it's needed on the grid is huge potential. And that's part of what we're working on. NSCC had the good fortune to work with Nova Scotia Power and other partners to install the first, it's called a bidirectional charger. So it allows you to take some of the charge from the vehicle and put it back into the building and back into the grid. That's not this one that's pictured here. It's a larger one called Corytech that we installed at our Middleton campus. But interestingly, the one that's pictured here is a wall box. That's a wall box Pulsar, which doesn't have the bidirectional capability. But their next one that's coming out that is not certified for use in Canada yet, but we want to test one, has a bidirectional capability. So this stuff is coming. And again, hundreds of thousands of vehicles. It's small per vehicle, but it's a large impact if these systems are set up to be able to take advantage of that energy capacity. So how do you do that? And this is where we get a little further out of my lab and into much more the political, regulatory, economic, and legal questions is how do we make all this happen? And that part I don't profess to be an expert in, but this is what I would say about it, is all of the above. I mean, invest in these transmission upgrades. So, you know, we hear speaking about the Atlantic Loop and so on and other proposals to strengthen the infrastructure. We really need that. Like, there's proposals for 5 gigawatt or 5,000 megawatt offshore wind farms. Those should have, even if they're primarily for hydrogen production for export, which is a whole other topic we could get into, which, you know, I think is interesting. But they should have a connection to a wider grid so that when they have surplus, that can be part of our green energy. Investing in centralized storage. And as I mentioned, I think we really should look into the potential of pumped hydro storage as centralized storage, particularly in areas in our region where we have sort of mid-scale mountainous regions. Where it gets closer to the work that I do is the question of setting the conditions for private investment in distributed energy storage. And the reason I've written it that way is distributed energy storage is different. If you're doing a great big transmission upgrade, you're doing a centralized storage plant, these are big projects. So they need government support, they need integrated resource planning, like they need the whole, the big project approach. Distributed energy storage is something that if you give the individual customers the right tools and the right reason to do so, like why would I do this? You can leverage a whole bunch of private investment. And the electric vehicle is a great example. Lots of people are already choosing to buy an electric vehicle, and they don't necessarily yet have the ability to also use that vehicle as grid storage. In fact, may not even know that that possibility exists. But they're probably going to have an electric vehicle anyway. That's an enormous opportunity to leverage the private investment that they made in that electric vehicle. And that's the kind of thing that I'm talking about. And incentivizing all of these affordable ways of storing energy. Just keeping an eye on the time, and I'll try to wrap it up soon because I know we want to get to questions. But just to say, there's lots of great work out there. And in the hot water demand controller area and the EV charger controllers and the smart, the bidirectional chargers, there's a lot of exploratory work going out there on like, how do you grease the wheels so that people will take this opportunity? And basically, they need to feel like they're included in the energy system. There's something they can contribute, like my hot water tank, my car, my house is helping solve this problem, and a little bit of a financial incentive. Everything as simple as you're going to get a credit. You're going to get even a modest credit on your bill every month for the privilege of the electric utility controlling the timing of when that's on, so that you can contribute to demand response on the grid. And just really involving people, making it affordable, targeting things at affordability and communities that are looking for equity in this situation. So that's basically what I would say about it. And in the interest of time, I'll leave it at that and open for questions.
Thanks, Wayne. Good morning, everyone. I'm Stefan Leslie. I'm the CEO of Research Nova Scotia. I'll be hosting the Q&A portion. With questions have been coming in as we go, but the first one is around the energy storage systems. You've mentioned a couple of them, but what are the ones that are most commonly deployed in similar jurisdictions that might have most immediate application in Nova Scotia?
So I would say it depends on that's different at different scales, right? So in the large scale, quite a few big projects are going ahead in different jurisdictions using lithium-ion batteries. And that's a reasonable way forward. There's, again, as I mentioned, there's increasing interest in the pumped hydro storage. And with those, there's a kind of a future question, which is, how available, like there's a tendency to think that the large scale battery storage is all going to be lithium-ion batteries. And I think that's a little bit unfortunate because in the kind of transition we're looking at, The materials to make those batteries are going to be so bought up by electric vehicles that I think it's better if we consider different kinds of large-scale storage. And then at the small scale, at the distributed scale, I would say lots of other jurisdictions are already doing things like load control. So controlling the water heaters, that's well on its way to becoming, I won't say standard, but that's done in Prince Edward, in Summerside, Prince Edward Island. They have a lot of them. They've started doing that in Berwick, Nova Scotia, and now Nova Scotia Power and Efficiency One are doing hot water controller incentives. So that's kind of well on its way. I think the next one there is better thermal energy storage units, like with heat pumps and so on, like the neothermal unit and the stash unit that I showed that we did some work on in the lab. That's in the category of coming, and the technology's there. It's just it needs more. People need more reason to do it, like more of an incentive to do it.
So I appreciate where you participate in this debate, but based on your observation, are the major challenges technological? Are they regulatory? Or are they social and consumer? So what is kind of preventing the rollout of increased storage capacity in those three broad categories?
Good question. And I don't think the main barriers are technological. I think sufficient technology exists to do most of this today, readily. That said, it's a tremendous effort to bring in place, for example, a distributed energy resource management system. Like that's something Nova Scotia Power is doing right now. It takes time. It's to build these kind of systems, and I think the main thing that really needs to be ramped up is the regulatory and the programming framework for these things to happen. Like it essentially needs to become easy. For someone to say, yeah, here's the offer. If you adopt this technology in your home, and it really doesn't matter much which one it is, but the key is it's a technology that will store energy and make use of it later. Simply, remotely, wirelessly, like you don't have to worry about it. There needs to be an offer that says, there's this great technology, it will help everyone, and you get a little bit of a credit for using it. And people are busy, like you don't have to pay attention to it. That stuff, that's already happening. Great examples out of Hawaii. I mentioned shifted energy with hot water controllers. They're based in Hawaii, and there's a good reason. So Hawaii is such a constrained grid as an island, and they've got so much solar power coming on that they had to do something. And so it's kind of a grounds for new programs for controlling water heaters so they soak up more solar energy and getting it back later and so on. The end result of that is not just the technology, that's important, but simple systems like people know if they sign up for this water heater controller, they're going to get $5 a month. It's just as simple as that. And they're never going to notice that their hot water is being controlled. We're almost there with that stuff. I think, I mentioned the electric vehicle bidirectional chargers have a huge potential as well. I think there is still a technology development and that rests with the charger manufacturers, the vehicle manufacturers, and also the interface of that with the regulatory environment, including the CSA and other standards bodies, to say, yes, you can start using this equipment here. And we've tested a few of them, and the ones we've tested are still a little bit early stage, like a little bit clunky to use, like not quite there. So that one I think needs a bit of development. And there's also this question, with any area where it's rapidly developing, you not necessarily know how it's going to end up. And a good example is the capability to take energy from the battery in the car and put it in the grid. That could be in the charger that's installed on site, or it could be in the car. And that angle is not really totally worked out yet in terms of what will dominate. But there's lots of advantages to just being in the car. Then you don't have to install a special charger. You can plug it into any charger anywhere and go on the app and say, okay, my car is available to feed the grid. I kind of think and hope it may go that way, but that depends on the car manufacturers. Like, that's a lot of design work to get that capability into the car, and they need to know that there's a market for that. So it all kind of rolls together.
So on the theme of bidirectional charging, which you've just been discussing there, there's a question about the two broad models that either the utility controls it when it needs to feed electricity into the grid, and then the consumer has an incentive to enable that to happen, or alternatively, the consumer controls it and you have presumably a price differential for when energy is being produced at the most costly or most carbon intensive way. A lot of the examples you've used seem to be more on the utility side, but can you talk about the pros and cons of each of those two broad methods and maybe ultimately where we'll see adoption here?
For sure, and that's a great question. In terms of who's doing the control of like when the thing comes on and off. Overall, and this, I could turn out to be wrong on this, but I think that for the most part, it'll work pretty well and people will be reasonably happy with utility just controlling it. And the reason I think that is, so, I'm kind of an energy geek. I'd be excited to be looking at the app and all the time saying, oh, when should my electric car be charging? Not. I've had to learn that not everyone's like that. Like, some people would just like to know, I think lots of people would just like to know, hey, I'm going to save on my electric bill if I sign up for this thing that controls when the car recharges. And as long as it's ready to go in the morning when I need to go to work, and I'm getting my credit, and I'm helping out, that's good. Otherwise I have to get back to bringing my kids to daycare. So that's my guess. It's just a guess, just based on like human nature and so on. But I think what I've seen is some of the best outcomes or systems with this is where there's a little bit of a hybrid of both, where you have the like hands-free options, like, okay, I'm participating and I'm getting my credit. I don't have to think about it again. But it's also great if they do have a good insight and app, and where like if you wanted to know how much your hot water tank or car or whatever had contributed to helping with this problem, you could go, oh, I helped the grid save 10 kilowatts today, or something like that. And I mean, the option of being able to make that decision, where that usually comes in my view, and what I've seen so far, is the opt-out, right? I mean, that's super important, especially if it's an electric vehicle. If you're on a set control system, and you know that the next day you have to leave really early for a really long trip, or there's something else that's changed in your daily pattern, you really need to have a simple button that says, no, I'm not participating today. I need this thing to be under my total control today. And they learn that very quickly when they start making a program like this. Is there needs to be an easy opt-out. And a good example, there's it's already starting actually, the trial of smart electric vehicle chargers. Now they're in Nova Scotia. Now they're not bidirectional, but it's chargers that the utility or someone who has the signal can control when it's charging and turn it down to avoid peaks. That's being trialed through Nova Scotia Power's Smart Grid program. And there is an opt-out. And basically, there's a condition that if you opt out too many times, like it's written there, you don't get the credit anymore, which is fair enough, I think. So that's a whole part of it, is what is the nature of the agreement between the utility and the end user about how this equipment's going to be controlled. I think that's really important to have right.
It's good. There's actually a question about how you incentivize, what's the marketing recruitment element to this. So there's clearly some interest there. A question around other sorts of fairly large investments, the example being in Halifax Regional Municipality, the deployment of electric buses. Is there an opportunity to use that already in train investment to optimize it for this purpose as well? So rather than just replacing existing diesel, I assume they're diesel buses with electric, can you also use it as a grid level storage solution?
Excellent question. And yes, Halifax Regional Municipality is about to replace, I think it's more than 100, but I could have the number wrong, but it's a significant number of buses, replace diesels with electrics, which is a great step forward, even on its own, just in terms of reducing emissions. And in principle, yes, those buses could be also providing those grid services when they're not on the road. It's a little bit tricky with transit buses because they tend to be worked pretty hard. And so in terms of long duty cycles, and they probably only have so much time to get charged up to begin with, and they need a lot of electricity to do that. So with I guess a work schedule that rigorous, and clearly, I mean, if it's a transit bus, the priority is providing transit. So I think a public transit bus in an HRM context is probably not going to provide very much value as in terms of sending energy back into the grid, because there's a good chance that all the time it's at the station, it's got to be charging. So in that case, you almost have the opposite issue, which is like, how do you manage like upgrading this place where they park all the buses to charge, to provide that much charge is an enormous electrical upgrade. So that it's like adding a village to that location in terms of the amount of electricity. So that kind of has its own issue. But one kind of bus that is actually super useful in this context is the school bus, which we have lots of school buses. There's a great producer of electric school buses in Quebec, Lion Electric Buses, and different jurisdictions are getting them. A school bus has a much less demanding use pattern. It has way more hours when it is sitting there and is already charged, and so could be. So across really North America and around the world, there's multiple projects going on now to use school buses as grid support. And I think that's we could definitely do that here.
So I appreciate we've been focusing mostly on the storage component to it, but at the beginning you mentioned local or distributed grid level storage and then the transmission side. Can you speak a little bit to what's required, not just to increase the transmission capacity if you have electrons moving around as you generally increase the load, but what investments are required to manage a grid with a greater number of storage devices coming off and on at different times, and the wind blowing and not blowing, being fed? How do you actually invest in a grid that will enable that to happen?
Yeah, excellent question, and definitely a huge technical challenge to manage all of that. Just on the transmission, just key upgrades in the capacity of connections between regions that have a lot of wind power and regions that have a lot of hydropower. So i.e. Nova Scotia, Newfoundland, Labrador, and Quebec, and the New England states. It's just ripe for having a stronger system. And then you might ask, okay, then how is that going to operate then? The commercial arrangements then become very interesting, because if we have a huge surplus of wind power, let's say coming out of Nova Scotia on a particular day, ideally there's somewhere to sell that, like into Quebec and or New England, and be able to purchase it back as hydroelectricity later when there's no wind. So I mean, that's complex, and I certainly, the job I'm working at, I don't claim to be able to solve that issue. But when you look at the distributed parts of the system, I think the important part is the distributed energy resource management system. And that's actually fairly complex software, which there's different providers of them and so on. but essentially it's a system for managing these multiple points of contribution on the grid. So a system where you can enter that, where it essentially knows that there's solar on all of these buildings, and if there's batteries in these buildings, and we have this many electric vehicle bidirectional chargers and water heater controllers, some large batteries, and basically attempts to integrate all of it with weather forecasting. So now it's fairly well developed to know 4, 8, 12, 24 hours ahead approximately what your wind speeds are going to be. And so planning for the next few days, how many water heaters are we going to try to control, or which battery are we going to need, or how much can we get from Newfoundland and Labrador. It's obviously very complex, but I mean, running the grid is already complex. I mean, before any of these distributed energy resources were possible, there was already a room full of computers managing the electrical grid. So this essentially adds some complexity to an already complex problem that we've already been kind of solving for years.
Yeah, and there's a question kind of getting in on that about the need to align these R&D, the development of the research capacity that research has developed in altering our approach, the need to align that with government policy making and incentive structure existing within the regulatory and the industrial area. So can you speak from where you've been participating in this, in how that integration is happening, how that conversation is happening, if we need to see significant changes to our conception of how energy is produced, transmitted, stored, and used, both in timing and in type?
Yeah, and I think we're already seeing that change in conception. I see that we're kind of in the early stages of a very large transition in how we view how the energy system works and everyone's role in it. Like, it's relatively recent historically that anyone could contemplate contributing energy back into the grid, right? That started with net metered solar. And I'll date myself here, but I was part of the first one of those that went in New Brunswick. The first net metered solar installation was 2001 to 2003. So not that long ago in the history of the electrical system. So what I see is this kind of ongoing. It's almost like bootstrapping. It's because we look, okay, what are the available technologies going to be? What do we have now on the ground? What kind of system can we put in place that incentivizes each one? So it just kind of it seems to go incrementally. And then it's punctuated because planning around the electricity system goes through integrated resource plans, which tend to happen every 5 years and get approved by the Utility and Review Board. So it's punctuated by these kind of lengthy and arduous planning exercises. So I'm always encouraged, basically, when ideas that seem like they're going to be very helpful are getting into the big integrated resource planning process, and the folks at that level are talking about them. And the most recent one showed that progress. I mean, the Nova Scotia one, that it identified that we need to get more storage. It wasn't yet saying that it should be distributed storage. It still is more focusing a bit on essentially big batteries, which is a good step forward too. But I think there's more options, that it's becoming clear to everyone that there's more options to be considered that may be more affordable and more participatory.
So we have about just under 5 minutes left. So I'm going to try and squeeze in a few more questions. There's a couple around the feasibility or viability of pumped storage as one of your options. And I presume that one of the reasons you've put that on the table is that it's relatively simple, proven technology deployed elsewhere. But can you speak to its suitability in Nova Scotia? Do we have the height differential located close enough to water sources of sufficient volume that you can actually take advantage of it? Are you aware of previous attempts in the past to develop pumped hydro facilities near St. Peter's in Cape Breton?
Yeah. So again, excellent question. So yes, definitely in Nova Scotia, we have regions, geographies that are quite suitable for pumped hydro, and in particularly the higher places. I would include the Cobequid Mountains in there, but probably I would say especially in Cape Breton for a couple of reasons. That proximity to water, they're actually quite significant height differences, and the placement of electrical infrastructure. Because if this is a large pump storage installation, you'd want it to be pretty close to a large transmission line, and the kind of backbone of large transmission lines comes out of Cape Breton for historical reasons with the coal-fired power plants there. So Cape Breton's good potential, and it would have been in the forget exactly when it was, but sometime between 2000 and 2008, there was a proposal for a pumped hydro storage plus wind energy project kind of near the Bredor Lakes. And from a technical perspective, I think it was a pretty reasonable proposal. So their proposal was to pump water out of an existing lake and build a reservoir at the top of the hill. And they were going to have 80 megawatts of power going back and forth. I think, reasonable technologically, reasonable scale. They did not go ahead as proposed. And in fact, there was considerable protest about the idea, including among several Indigenous communities. And I would say rightly so. Like first of all, the proposal right out of the gate was to use a natural lake as the lower body. And sure, that may cost less, but you have to ask and answer the questions of how much water are you taking from that lake, and what effect does that have on the levels of the lake? Could that affect Atlantic salmon habitat? Like there's a lot of things that need to be looked at in a proposal like that. Also, I think the community engagement, and in particularly the engagement with Indigenous communities, was not well done. So I think definitely there's potential, and I'll just add that I've in some of my courses, I've had students do their projects on studying the potential for essentially where you could do pumped hydro in Nova Scotia, and they've come up with some, I think, pretty reasonable sites. And some of them looked at existing historical infrastructure like abandoned quarries or mines, or which I think is interesting. If we can find ways to use places where there's already been a disturbance, like already been a reservoir or mine dug out. So I think there's potential, but I think it needs more attention, and it needs more research work, and it needs to be done in partnership with Indigenous communities and with local communities.
So we're going to have to leave it there. There's questions left unasked and unanswered around the smaller scale hydro, around the difference between day and week storage versus seasonal storage. So demand over the course of a year, which we haven't got to, but just so those who have posed those questions, we have captured those. We'll send them over to Wayne, and with your support, Wayne, we'll make sure that those questions get to you, and you can respond to those. But unfortunately, we don't have time to get to them in this group. So I'd like to thank Wayne, you for your time sharing this information with us, and with the very large group that has attended and spent part of their morning with us, learning about this really important topic. I hope you have taken something valuable away from this. And thank you again, Wayne, and appreciate everyone's time. And I wish you the best rest of the day. Thank you very much.